Good morning. I think I'm in a pretty dangerous spot because I'm standing between you and lunch break. Yeah? So I try to make this very interesting to you so you don't think about food. Okay, as Uma mentioned, GE has a long-standing history of innovation. And I think the reason that GE is so successful over the long haul is really exactly that. It's the innovation spirit, starting from our founder, Thomas Edison, right? Is perhaps the most famous inventor in history. But I would like to share you this quote, though. I think that's the essence of GE innovation. That is, I found what the world needs, then I proceed to invent it. So innovation for GE is always rooted from the needs of the market and the trend of the market development. Okay, it's not for the sake of ivory tower discovery, scientific discovery. It's really the bridge between science and technology, and then making it a product that our customers can use. Okay, so there's a long history. I'm not going to bore you with each individual, but the point is there are many history-defining moments in GE's innovation. A lot of the products that we introduced in the world are first commercial viable product. Again, it's not the science, but it's the commercial viable product. For example, very early on, the first medical diagnostic X-ray machine that can be used in a clinic is introduced by GE, right? And that history has gone on for many years. A jet engine, a gas turbine, a CT scanner, MR scanner for medical again, and wind turbines, and now most recently, electrification for transportation and so on. So when you think about GE, it's really a combination of high-tech businesses with aviation, power, energy management, smart grid, home and business solutions. That's our tradition, right? Starting with lighting and appliances, all the way to oil and gas exploration technology, transportation in terms of diesel engines, as well as mining equipment, healthcare in large equipment that are used in hospitals, big and small, right? And even life sciences over the last dozen years. So there are really very diverse industry and technology involved in GE's innovation. And the core of that innovation is our continued investment in people, talent, and the culture, right? There are over 50,000 people engaged in research and development out of 300,000 employees worldwide, and we invest about $5 to $6 billion a year. In GE's industrial revenue, that it represents about 5 to 10% of total global revenue. So that's a huge investment, and we don't do it alone, obviously, right? We do it in a context of, again, market as well as collaboration partners. Global presence is very important for GE, but it's not the case if you roll the clock 15 years back, right, before the early, before 1998, 97. So for about 100 years, research is focused in North America, right? That place in upstate New York that is funded in 1900 with Thomas Edison. Arguably the earliest industrial research lab in the world, and is still the largest, I think, in the industry today. Over 2,000 people there engaged in research. But over the years, we have developed footprints in places like Bangalore, India, Shanghai, China, Munich, Germany, and now we're starting one in Brazil in a couple months. I was hoping that they start earlier so that we can attend the inauguration and World Cup, but there are construction delays in Brazil as usual, and we'll hopefully operate in a couple months. But the point is, we are now very global in our research and development efforts, spanning from all corners of the world. And we're also starting to add more within the US, most notably in California, the one on the right-hand side, in Silicon Valley. And I'll talk about why we expanded that about 2 or 3 years ago, a little later. Okay, so I think this morning our speakers talked about innovation process, and the survey showed a lot of best practices and also showstoppers. I want to show you some of the innovation processes that GE has that has been very successful over the last century. First of all, we centered our innovation process around you meaning customers, okay? So we have engagement with many other people, including universities, other companies, big and small, governments, and venture capital and small startup companies as well. So it's really a very diverse and open environment where ideas can come from everywhere. I'll spend a few more minutes later on why we need to do that in an open environment. And the last bubble on the right-hand side, in country for country, and also solving problems in your local region, is really our strategy over the last 10 years or so, particularly in China, India, and emerging market like Southeast Asia, where we started to understand the market better. Instead of being an exporter from the North American market, we are now a creator of technology and ideas that are rooted in the market, in the region, okay? So those are very, very important transformations over the last decade for a company like GE. So developing world-class innovation process have to start with talent, right? This is a picture just to show you, many different disciplines and technical areas that GE's 50,000 engineers are composed of. I would say GE is probably one of the few companies who does research, which is 5 to 10 year horizon, as well as product development, which is delivered to the customer this quarter, this year, next year. But the distribution is roughly 10% research and 90% development. So it's really small R and big D, okay? But even the small R, I should say, it's still about 3 to 4,000 people globally, and we spend about 600 to 700 million US dollars every year on the technology that can go into our next generation product. So that's really how organizationally we're structured, and talent in terms of pulling people from different disciplines to solve complex problems that we face. So this is a very important chart. I know it's also an eye chart, but I'm going to talk a little bit more detail on this chart. Now, innovation, can innovation be a process-driven? The answer to me is yes, okay? Particularly for a large company like GE. GE is probably too well known for having processes, right, within the company. And sometimes processes can be bad, can suffocate, creativity, in my opinion. But in this case, this innovation process provides a high probability of success year and over and over again. So this starts with the inputs, right? What are the great ideas that you can get, right? There are many sources of inputs. So we can get them from the GE businesses, right? Each business, obviously, they're fighting for market share and profitability in the market, and they know the competitive landscape very well. So they tell the research development team, what do I need in 3 years, 4 years, 5 years? So there is a product roadmap. In many cases, we call MGPP, multi-generational product plan, right? So according to the product plan, you should come up with a technology plan, MGTP, right, that provides the necessary technology to deliver that product plan. So that's very important. Customers, right? Customers many times can tell us what their challenges are. That's why we need to engage customers very early in the innovation process, okay? The other one is venture capital, mergers and acquisition activities. We learn a lot from those activities. Sometimes we may not come up with an actual acquisition, but you actually learn in the process, right? And we get a lot of great ideas from startup companies as well, particularly in today's market. You can think of, healthcare market, all the mobile devices and also the renewables and green technology, right? They're everywhere. A lot of great companies come up with great ideas, but they do not have the engineering know-how or the financial backings of a company like GE to actually take it full scale, full speed into the market. So that's where we come in, and we can partner with smaller companies or venture capital to do that. Now, government agency, national labs, universities, obviously, they come up with great technology, science. In many cases, our research center team are the sensors, right, the eyes or ears in that academic area where ideas can come from the research group and brought into the product group in order to produce the next generation technology and products. So that's also a very good source of innovative ideas. And then the global scouts, that's an interesting one. We have, like I mentioned, 5 major centers of research, but we also have scouts in places like Israel. Okay, Israel is an interesting situation because it doesn't have a big market in Israel, but it does have many, many very smart people, well-educated people. Therefore, startup companies with great ideas but no place to go, right? That's exactly what we need from GE perspective. So, places like that, and also Russia, we have another office where we do that. And CEO, okay, the last one is not the least at all, in my opinion. I think Luciano's study showed that the business leader, right, the number one guy in the business needs to be the drivers of innovation. In GE, we made that happen because the business CEOs in each of the major 10, 20 billion businesses actually have regular reviews of the top ideas with our research group every quarter, at least once a quarter. They spend a whole day in the research center. Okay, we call them CEO programs, right? So there are a number of programs for each of, not very big, anywhere between 5 to 10, for each of the major business that the CEO has sponsorship, meaning that the CEO knows about it, knows the future impact of the program, and paying attention to it on a regular basis, right? So these are, I think, innovation processes where GE has been using for many years, and I think has been very successful too. Okay, so talk about process. I think we talked about the process a little bit already. What I want to use as an example is the first one. We call session T. T stands for technology, right? So with all the inputs from many, many people, how do you actually digest the information and come up with an operating plan? Where do you invest, right? There are hundreds of ideas, but you only have funding for 10. What do you do? So that's where the session T come from, okay? So we call session technology. This is a session where every year 3 major functions get together, okay? It's the business marketing, who are product managers responsible for the product roadmap, and who are also knowledgeable in the competitive landscape, right? They know who is coming up with new product in the next quarter or next year, who also have a good feel about the customer pain points or customer demands that are not met today, right? And then there are also business technology people who are responsible for delivering the product in the next 1 to 2 years, not very long term, but short term. And then there are research people, what we call global research technology folks. So those 3 groups of people get together based on the product line that I mentioned earlier, healthcare, aviation, oil and gas, energy. And they will discuss on an annual basis, anywhere between 1 day, 2 days, 3 day session, right? To understand what are the inputs from all the constituents that I mentioned earlier, right? And then prioritize on the opportunities that we need to invest for the next 3 to 5 years, depending on the cycle of the business, right? An aviation business can be 5 to 10 years. A lighting business can be 6 to 12 months. So that's how we do it on an annual basis with discipline. Right? I want to mention the word discipline because it is indeed a very disciplined approach on an annual basis where you come up with prioritized list of investments for the next generation, multi-generation products. So this is really an important a process where has a long impact on the health of the business. But I should also say this is not a fixed process either. You cannot say, okay, everybody go to sleep, do your own thing, and then come back on an annual basis. That doesn't work, right? So there are iterations. The map is not fixed. There are iterations on a daily basis, monthly basis, and there are discussions going on all the time between research people, the product development people, and the product marketing people. So this is ongoing, 365 days a year. But for that particular time in the year, usually in late spring, early summer, we have a session where we fight out, right? We have different opinions, we debate, and then in the end, we have a roadmap for technology development. Okay, so I want to spend the next few minutes on innovation and collaboration and what it means and how important it is for our innovation process. So this is a picture where a couple months ago we had a big meeting with customers on electrification, right? People who are engaged in shipbuilding, who are engaged in mining industry, many other industries. Customers who wants to have more electrical-driven technology into their operation versus diesel or the traditional way. And GE comes in, we're the technology builders, but we need to understand how it's going to be used in a customer context. So this is a great example of customer-driven collaboration, where you get more insights and also come up with new ideas of how to use or how to develop further your technology to become successful in the marketplace. This is a very too complicated chart, but the point is a collaborative research development project should have ideas from everywhere. And I emphasize the point of co-creation because in the past 100-some years, GE, even ourselves, has been quite closed in our innovation process. It's only in the last 10 years or so we started to become much more open, realizing that engaging customers early, bringing in partners, right, to come up with solution is important. I'll give you a good example. Maybe that can drive home better. Maybe 3 or 4 years ago, right, we were in China. So China makes the most steel, right? The steel industry is the largest in the world. But it also produces a lot of pollution, and it's very energy inefficient. So by going to the steel mills in China and understanding the problems, we identify one particular headache that they have. That is, they have a lot of waste heat in their steel-making process, like blast furnace gas or coke oven gas. They don't know what to do with it, so they just burn it in a boiler and make electricity, right? It's only 10, 20% efficiency in thermal efficiency in reclaiming the energy that's still in the waste heat. So in GE, we certainly have much better technology in gas turbines, in gas engines, but the problem is they are designed for natural gas, right? They're designed for pure, clean natural gas, not for the kind of waste gas from a steel-making process. So problem is clear. How do you come up with a solution to clean up the gas? In some cases, maybe concentrate the gas to make it suitable for a gas turbine to burn. In the meantime, producing 40% to 60% efficiency, right? So this is not a traditional GE technology where we just sell a product, the customer is happy. No, we have to come up with partners, work with the customer, and do a prototype in the steel mill, and then eventually become a very successful solution It's a win-win solution because the steel mills, economics improve significantly, right? And also reduce the pollution they produce. But on the GE side, we sell hundreds of millions of dollars more gas turbine. That the turbine was not even designed to use this, in this purpose. So this is, I give you a great example of a solution where innovation is not in technical, advancement, but in solution, in understanding the use and application, and able to come up with, collaborative efforts to deliver a solution based on mature technology in many cases, right? Okay, so partnership, okay, I think I already talked about this. So there are universities, governments, companies everywhere that we partner with. I think at any moment we have more than 300 collaborative R&D projects going on with universities or companies. And one particular exercise or practice we did was what we call innovation centers. Okay, so these are in Chengdu, Xi'an, in China, in the western part of China, where we are closer to customer. Right? The steel mill example, the petrochemical industry example, food and beverage industry example, many examples where it's about solution. It's not about advancing the state of the art in technology that are the most important in our innovation process. And I think it may have a similar application in many other countries, right, in Southeast Asia as well, where you may identify local needs that are not satisfied by one or two particular product, and you need to be closer to your customer to come up with solutions. Okay, now let me switch gears quickly because I only have a few more minutes. Future technology, okay, if we have a crystal ball, okay, what are the future technology that GE is working on, we believe can change the game in the industries that we serve? I think there are two major technology directions and one major trend. Okay, the one major trend we already discussed, that is open innovation. I think it will continue to define the innovation landscape for many industries, not just GE. But the two major trends in our industry, which is infrastructure, healthcare, the big needs of the society, is going to be, number one, what we call industrial internet. Number two is advanced manufacturing. Okay? One is very sexy and new, the other is the good old manufacturing. Okay? I'll tell you why. Industrial internet, okay? So we all know over the last 10 years or so, the consumer internet has really redefined how we play, how we purchase, right? How we live, even how we communicate. But the advent of the internet capability, coupled with the big machines that are more intelligent today, right? Companies like GE, we don't make small gadgets, right? No pun intended for Apple, but we make big machines that are complicated. And there are a lot of sensors in the machine that are producing data every second. Today, only less than 0.5% of the data are being used. So it's a big waste already. So with more sensors, more available data that we can get real time, there's a huge opportunity to do analytics and make use of the data to drive decisions, right? You can think of remote diagnosis and monitoring diagnosis to improve efficiency of your machine. You can also predict the unscheduled breakdowns, or unscheduled maintenance of many of your machines. If you improve efficiency by 1%, 2%, it's a huge gain for many of the industries that we serve, right? So it's a huge opportunity. It's a big financial payback if we get it right. And I think the time is right today because the data that we generate from all the machines is already growing faster, 2 times faster than many of the consumer data that we're generating in terms of growth rates, right? And the number of machines obviously already surpassed the population a couple of years ago. And I think it's going to be an exponential growth of smart machines with data. So the key is how do you make use of the data? Right? How do you analyze them and be able to make use of the trends and predictive capabilities that you can derive from all the data that is generated. So for a very simple assessment, measurement assumption, it's 1% game can produce hundreds of billions of dollars of profitability for our customers. For the sake of time, I'm not going to go more detail into this, but the point is it's going to define the future of the industry. Now, let me turn to manufacturing. What's changing? Okay? Manufacturing is not the good old machine shop anymore. Today, again, because of data, because of internet, because of sensors, the physical and digital world are closer than ever. Right? The factories of the future are going to be brilliant, meaning that there will be a lot of intelligence going into a manufacturing process or supply chain, for that matter, including your sourcing partners. They're going to be very, very efficient. The game will be played on how you can leverage the advancement of technology to make your supply chain most efficient, right? And for that matter, there are technology advancements as well in the manufacturing technology. 3D printing is a great example. For GE, what that means is making jet engine components by 3D printers, right? Not plastic parts that you can play with, but actual functioning metal parts that goes into an aircraft engine. The first one has already been made and put in use. It's a fuel nozzle that goes into the engine. And the one that we're working on actually is the leading edge blade on the fan composite fan blade, as you can see on the front of the engine. There is actually, the fan blade is actually made of carbon composite. Right? You may not want to fly on it. It's carbon composite, come on. But we do have metal leading edge that enforces it and make it very, very strong. And that piece is going to be 3D printed as well. Okay? So make it very flexible, efficient, and you can tailor your material property and mechanical property by how you make it and what material you're going to use. So flexibility in manufacturing process is enhanced tremendously with the advancement in material science and manufacturing technology. Yeah, so with limited time left, I'll just leave you with this last page. I started by saying GE is really focused on market-driven innovation. So the open innovation process that everybody is doing now, I think will define how we can combine the market demands and the market trends with our own technology development. And so, combining the advancement in technology and market needs, and then use open innovation as a process, we hope that we'll continue to be standing in front of the leading edge of all the companies, and then continue to become very innovative in the industries that we serve. Okay, with that, I want to thank you for your attention. Thank you.